On May 3, 2024, the Long March 5 rocket stood ready on the launch pad at the Wenchang Satellite Launch Center in China's Hainan province. The 57-meter-tall rocket, with its distinctive orange insulation and 4 strap-on boosters, carried the Chang'e-6 lunar probe, a complex spacecraft weighing approximately 8,200 kilograms. The boosters, powered by YF-100 engines, burning liquid oxygen and kerosene, provided the initial thrust to lift the massive rocket off the pad, generating a combined thrust of 4.8 million pounds force. As the countdown reached zero at 5:30 a.m. Eastern, the Long March 5's engines ignited and the rocket began its ascent into the sky. About 2 minutes into the flight, the strap-on boosters exhausted their fuel and separated from the core stage, falling back to Earth as the rocket continued to climb. The core stage, powered by 2 YF-77 engines burning liquid hydrogen and liquid oxygen, continued to propel Chang'e-6 towards its intended orbit. Approximately 12 minutes after liftoff, the Long March 5's second stage, equipped with a pair of YF-75D engines, also fueled by liquid hydrogen and liquid oxygen, performed its first burn to place Chang'e-6 into a parking orbit. This initial orbit allowed the spacecraft to coast briefly before the second stage reignited for a translunar injection burn, setting Chang'e-6 on its trajectory towards the moon. The translunar injection burn, lasting roughly 14 minutes, accelerated the spacecraft to a velocity of 10.9 kilometers per second, the speed necessary to break free from Earth's gravitational influence and begin its journey to the moon. Once the translunar injection burn was complete, the second stage separated from the Chang'e-6 spacecraft, which then deployed its solar arrays and began its 53-day mission to the lunar far side. With the spacecraft now on its way to the moon, the second stage is set for a historic mission that could significantly advance our understanding of the Earth-Moon system and the early history of the solar system. The Chang'e-6 mission is a complex endeavor involving 4 spacecraft working together to collect and return samples from the far side of the moon. The mission architecture is designed to overcome the challenges posed by the moon's tidal locking, which prevents direct communication between the far side and Earth. The mission begins with the Chang'e-6 orbiter guiding the lander to its destination within the Apollo crater on the lunar far side. To enable communication, the Chang'e-2 relay satellite, launched in March 2024, will act as a vital link between the lander and mission control on Earth. Upon landing, the Chang'e-6 lander will deploy its instruments and collect up to 2,000 grams of lunar regolith using a drill and a scoop. Once the samples are collected, they will be stored in the ascent vehicle that will launch from the lunar surface to rendezvous with the orbiter. This critical phase requires precise maneuvers and advanced guidance systems to ensure a successful docking. After the samples are transferred to a re-entry capsule within the orbiter, the capsule will separate and begin its journey back to Earth. The re-entry capsule will employ a skip re-entry technique to slow down before making a controlled descent to the surface. The successful completion of the Chang'e-6 mission will provide scientists with valuable samples from a previously unexplored region of the moon and demonstrate China's growing capabilities in complex, multi-stage deep space missions. If successful, the Chang'e-6 mission could significantly advance our understanding of the Earth and Moon's history and the early solar system's evolution. The landing site, Apollo crater, lies within the South Pole Aitken (SPA) basin, a gigantic ancient impact basin on the lunar far side. Scientists believe this region holds tantalizing clues to a number of moon mysteries, making the added cost and complexity of a relay satellite worthwhile. Studying the lunar samples could provide insights into the lunar dichotomy, or why the near side and far side are so different. The SPA basin readily excavated lunar mantle materials, which may be contained in Chang'e-6 samples. These materials are crucial for studying the lunar magma ocean model, as the lunar mantle is a direct product of the solidification of the lunar magma ocean. Additionally, Studying exotic impact-related materials like impact breccias will be revealing as to the history of the Earth-Moon system, potentially shedding light on the late heavy bombardment hypothesis. The Chang'e-6 mission also carries international scientific payloads from France, Sweden, Italy, and a Pakistani CubeSat, reflecting Chinese efforts to boost its international cooperation in space exploration. France is providing the detection of outgassing radon Dorn instrument, which will detect radon outgassing from the lunar crust. Sweden, with ESA support, will contribute the negative ions at the lunar surface, or NILS, payload, and an Italian passive laser retroreflector will also be on board. The inclusion of the 7-kilogram iCubeQ CubeSat, a collaboration between Pakistan's National Space Agency, Suparco, and China's Shanghai Jiaotong University, is particularly noteworthy. This collaboration demonstrates the growing ties between Pakistan and China in the pursuit of scientific discovery beyond Earth's bounds. While the international payloads have been publicly disclosed, there's an interesting twist to the Chang'e-6 mission. Following launch, the spacecraft maker, the China Academy of Space Technology, or CAST, revealed an image showing a previously undisclosed rover attached to the mission lander. This surprise payload has raised questions about China's intentions and the possibility of other secret instruments on board. Although the details about this rover are scarce, a post from the Shanghai Institute of Ceramics provides some insight into its potential capabilities. The rover is believed to carry an infrared imaging spectrometer, a tool for analyzing the composition of rocks, soil, and regolith on the lunar surface. By measuring the absorption and emission of infrared radiation, this instrument can identify specific minerals and compounds, providing valuable data on the Moon's geological history and evolution. Additionally, the spectrometer could potentially detect the presence of water ice, a crucial resource for future lunar exploration and long-term human presence on the Moon. The inclusion of this secret rover is not an isolated incident in China's space missions. The country has a history of incorporating surprise payloads, such as the disposable spacecraft released during the Tianwen-1 Mars mission to capture images of the orbiter and rover at various stages of the journey. These bonus spacecraft demonstrate China's technological prowess and provide valuable data for future missions. However, the lack of prior disclosure regarding these payloads raises questions about transparency and the full extent of China's objectives in space exploration. While the scientific value of these surprise payloads is undeniable, their inclusion without prior announcement does raise some eyebrows. What else might China be hiding on this mission? And why the secrecy? Regardless of the secret payloads, the Chang'e-6 mission is a testament to China's growing capabilities and ambitions in space exploration. It's part of a broader lunar exploration program that aims to establish a permanent lunar base, the International Lunar Research Station (ILRS), in the 2030s. China plans to follow up Chang'e-6 with 2 missions to the South Pole of the Moon, Chang'e-7 in 2026 and Chang'e-8 around 2028. Beyond this, the country aims to launch its first crewed lunar missions by 2030, paving the way for the ILRS. As we await the landing of Chang'e-6 on the lunar far side in early June, the mission's progress will be closely watched by the scientific community and space enthusiasts worldwide. The samples it returns could unlock new secrets about our nearest celestial neighbor and our planet's own history. At the same time, the revelation of the secret rover and the possibility of other undisclosed payloads will undoubtedly fuel speculation about China's true intentions in space. As the country's space program continues to grow and evolve, the international community will need to balance the benefits of cooperation with the need for transparency and trust. One thing is clear: with Chang'e-6 and the missions that will follow, China is establishing itself as a major player in the new era of lunar exploration. As we watch this mission unfold, we can only wonder what other surprises and discoveries await us on the far side of the Moon. The successful launch of Chang'e-6 marks the beginning of an exciting new chapter in lunar exploration. With its ambitious goals, international collaborations, and secret payloads, this mission is sure to capture the world's attention in the days and weeks to come. As we eagerly await the first images and data from the lunar far side, we can only speculate about what China's secret rover and other potential hidden payloads might reveal. Will they uncover new scientific insights, or will they raise further questions about China's intentions in space? Only time will tell, but one thing is certain: the Chang'e-6 mission is a bold step forward in our quest to understand the moon and our place in the universe. This is the Space Technician, signing off for now, and I'll see you, Space Cowboys, in the next one.